PT, PT is the tangent to the circle at T. The centre is at O. MO equals MP. Good to know. If PT is 3, find the radius of the circle. Right, that's not as bad as you think. Right, so get this. Would everybody agree that the line I drew is a radius? Would everybody agree that that's 90 degrees? The angle OTP, because it's a tangent, right? Now, if I let the radius be equal to R, what's O to N? R. What's N to P? R. So would everybody agree that that's 2R then?
Wait, sir, is N on the circle?
N is a point on the circle, yeah. Doesn't specify it, does it though?
Are you actually assuming that?
Poorly drawn question, but yeah. It's meant to be. But you're right, it should be clearer and it should be spelled out better. There should be a point there to signify that. So you're technically right, Charlie, but that's what they intended. Otherwise, no other way doing it, to be honest. Alright, what's P to T? 3. We're going to do Pythagoras' theorem, aren't we? The goal of the exercise, 2R squared equals? Anybody? 4R squared equals? R squared plus 9. 3R squared equals what? R squared equals? 3. R equals the square root of? Otherwise known as 1.732. Any questions? You're right to be confused by that because it never specifies that N is on the circle. Does it? No. So it's poorly created question. Right, shall we move on?
Sir, can you just leave that answer as a cert?
It doesn't specify what way it wants the answer, so cert is grand. I always double up. I just have a habit of doubling up on my answers. I consider it a good habit as well. But anyways. Alright guys. Find in terms of pi the area of the circle described in the square PTWQ. Given that PR is root 5. PR is root 5. QR is 2. Well, I think my intention would be to get this length here, wouldn't it? Yeah. We'll just call it D for diameter. Why am I calling it D for diameter? Because if you bring it down, it's the diameter of the circle. Okay, so here's what we'll do. D squared equals root 5 squared plus 2 squared. Put it all in your calculator. D squared equals 9. D equals 3. Radius therefore equals 1.5, which is half of it, isn't it?
Sir, how would you put that in words? If you say they said prove, how do you say that PQ is the diameter of the circle?
Because it's inside a square and it's touching both sides of the square. Okay. End to end of the diameter has to be the same width as the square. Otherwise, the circle wouldn't. Otherwise, the sides of the square wouldn't be tangents to the circle. It's because the sides of the square are tangents to the circle.
Oh, I see now.
Because they only touch once. All right. Now. Area equals pi r squared. Area equals pi times 1.5 squared. What's 1.5 squared? 2.25? Who got 2.25 pi? Alright. We all good? Same thing. Shall we drive on? Alright, let's keep going. 28. An equilateral triangle has sides of length 8. The perpendicular height of the triangle is A root B, where B is prime. Find the value of A and the value of B. Now, somebody told me this the other day. I think it was Sharia. And this trick only works for equilaterals and isosceles. Does everybody get that? If you draw a line down the middle, and once again, only works for equilaterals and isosceles. For argument's sake, if this was 60 degrees, it would split it 30-30. Does that make sense? it was an isosceles triangle and that was 100 degrees, it would split it 50-50. And it also splits the bottom in half as well. Does everybody get that? So it'll be splitting it 4-4. Is that cool? This only works for isosceles and equilaterals. Now, what's the hypotenuse? 8, isn't it?
Yeah.
And we're going to find out the height h. 8 squared equals h squared plus 4 squared. 64 equals h squared plus 16. H squared equals 48, is it?
Yeah.
And what's the square root of 48? 4 root 3?
Yeah. 43.
There you go. What?
You have to say the value of A.
Oh, yeah. A is 4 and B is 3. Alright. Find the area of the triangle. No bother. Shh. Connor, how'd you find the area of a triangle? O'Reilly. Sorry, O'Reilly.
Base 5 height.
Half base times height. So what's the height?
4 root 3.
And what's the base? What?
Or 2. 4.
It's not 4 actually. It's 2 4s combined, which is 8. So we're going to do a half the entire base times the height. Okay, and what you get when you do a half base times height? Half 8 times 4 root 3. 16 root 3 is in centimeters, is it? Centimeters squared.
You could have just done 4 root 3 because you had like half of it already. You had like the 2 already made. You don't have to half it, you can just like double up.
Yeah. You happy now? Fair enough. Alright, so what have we done so far? 24, 26, 28, and now 32, is it? Alright. Now, 32. Would everybody agree that the small triangle ADE is 1/3 the size of ABC?
Yeah.
Why?
I divide by 3.
They're similar triangles, aren't they?
Yeah.
Do I have to prove they're similar triangles? No, it's just asking you to find AE. It's not asking you to prove that AE equals something. It's find. So that's 3. That's a 9. That means ABC is 3 times bigger than. 3 times bigger than what? ADE. Divide 12 by 3. What you get? 4. And now we're after AE, aren't we?
Yeah.
And then x squared equals 4 squared plus 3 squared. X squared equals 25. X equals 5. We cool? Alright.
Could you also find the hypotenuse of
The bigger one and divide by 3. You could also find AC and divide by 3.
Yeah, that's what
Yep. All good.
Sir.
Yes.
After 33, 34, you did 35. We didn't have for homework, but it looks really complicated.
Okay.
Great eyes.
Now. Okay, lads, you ready? In the triangle ABC, AY, it's a ratio of 2:3. Okay? Which is technically a ratio. If I was to add the two of them together, what would I get? So 2:5 for the small triangle compared to the big triangle if I want it. Don't know if I want it yet or not. Alright. XY is parallel, so they're similar triangles. Is everybody cool with that? So I sort of do want it as 2:5. Alright? I have an idea. You could either make up your own numbers, or you could, so I'll give you an example. I'll show you 2 ways of doing it, right? So this is AXY and that's ABC. So would everybody agree it's a ratio of 2:5? How did I get that?
Adding 2 and 3 times.
Yeah. and it's 5, right? Now, here's what I'd recommend, right? For argument's sake, if this was a length of 10, okay, what would be the length on the other one? You divide by 2 and multiply by 5. So divide by 2 and multiply by 5? 25. I'm allocating the height of 10 and 25, right? And that'll give you the ratio, 5/2, won't it? Okay. Pick another number that's reasonably nice. I suppose I could actually just choose, might just choose 8. 8 be okay? Right. What do I need to do again? Divide by 2 and multiply by 5, and what do I get? 20. Now, what would the ratio of these two triangles be? So a half base times height, half 8 times 10, 40, and a half 20 times 25, 250. And what's 250 divided by 40? Or is it the opposite way around? Sorry, 40 divided by 250. What's 40 divided by 250? 4/25. Now lads, we're going to do something called enlargements later on. And you're going to see stuff like this happening, alright? So I'll give you an example. You don't even need to do that calculation. There's a general rule, alright? I'll just rub all this out. Give you an example. Liam, I'll give you an example here, right? If we all agree that the big triangle is 2.5 times, we all agree that the big triangle, each length is 2.5 times bigger.
Yeah.
I got that because it's 5/2. Give me a sec. Area is 2-dimensional, isn't it? So all you need to do is square that number. And when you square that number, you find out how much bigger the area is. So what would be the area then? 2.5 squared is, what's that, 25/4? But remember, you want the small one on top and the large one on the bottom. So what do I need to do with my answer? 4/25. You're going to get very used to that trick when we do enlargements. We're going to use that a lot. Okay? Yes. Otherwise we wouldn't do it. Alright. What's a 34? Alright. Interesting. Alright. I'm probably going to go after Q to T first. Yeah, we need to find Q to T. So, yeah. Now, alright guys, what am I doing again? Small triangle and big triangle. I'm probably one of the few people that always has to draw these out. 6, 8, 12. Would everybody agree that the big triangle is 12 divided by 8? What's 12 divided by 8?
1.5.
It's 1.5 times bigger. Is that cool?
Yeah.
Now, I'm going to get the number 6 and I'm going to multiply by 1.5. What do I get? 9. And that means QT has to be 3, because 3 plus 6 is 9. So 3. Alright. If TW is perpendicular to PR, great. Calculate WR. Alright. What have we not done yet? We haven't done Pythagoras' theorem, have we? And it's a Pythagoras' theorem chapter. And the other hint is it's also a 90-degree triangle, right? So we have 6. And what's the other side we need? It'd be great if we knew what WT was. Okay. And do you reckon it's going to have something to do with... It's probably going to be a similar triangle. It is a similar triangle. Because it has a shared side to the big one. Alright, so I'll run through a chart, no worries. Just give me a second. Alright. Now, here's what we're going to do. I'm going to use what's a PQR? If you can picture it. And Would everybody agree that's 90?
Yeah.
And then they have a shared angle, don't they?
Yeah.
Yeah.
And then
Third angle.
that's the third angle. I don't have to prove it. It's a calculate question. Okay. So what we're saying is, and what do we know about PR so far? Oh, I see it. PR is 12 and, is it 12 and 9, is it? When you do Pythagoras?
Yeah.
Yeah. Do Pythagoras to get PR, is that right?
Yep.
So Pythagoras to get PR, so PR squared equals 12 squared plus 9 squared. 225.
Yeah.
Square root it to get 15.
Yep.
Okay. And see the way we're looking for WR. WR is in between the 90 and the... Would everybody agree that WR is in between the 90 and the green one?
Yeah.
So we actually want to compare it to the number 9. But our problem is, how much bigger is the large triangle compared to the small triangle? Well, we can compare 15 to 6, can't we? Because 15 and 6 are stuck in between the blue and the green angles respectively. So what's 15 divided by 6?
3.5.
So what we're saying is that that triangle there, this triangle here in blue, is its lengths are the big triangle's lengths are 2.5 times bigger. Does that make sense?
Yeah.
The big triangle's lengths are 2.5 times bigger. So what does that mean about the number 9 then? We want it to be 2.5 times smaller. So divide 9 by 2.5 and what do we get?
3.6.
So 3.6 for WR.
Yep.
Happy days. Alright, on to 35 apparently. Alright. 3 circles A, B and C have radii 24, 10 and 6 respectively. They also touch each other externally as shown. Show that PQR is a right angled triangle. Right angled triangles have to obey Pythagoras' theorem. Agreed?
Yes.
If Pythagoras' theorem doesn't balance, it's not a right angled triangle. So I'll give you an example. A definite right angled triangle, and you guys have used this today, is 5, 3 and 4. Now we can actually ask this question. What I can do here is I can give you these 3 numbers and I won't tell you that this is 90 degrees. And I'll ask you guys, prove that this is a right angled triangle. And how'd you do it? You get the longest side, you square it, you put it equal to the other 2 sides. And if it balances, it's definitely a right angled triangle. If it doesn't balance, it's not a right angled triangle. Everybody got it?
Yep.
Alright, so what we're going to do here is the following. We're going to grab a line and we're just going to go U to U, U to U, U to U. Alright, that's for me that's 24 plus 10,
Yeah.
which is 34. This one's 10 plus 6, 16, and the other one?
30.
24 plus 6 is 30. I throw it all into... Will somebody get the calculator out and do that for me?
30 squared plus 16 squared is equal to 1056.
1100 and?
56.
That looks like it's going to be 1156 as well.
And then squared it,
Yeah. Sound good?
yeah.
It looked pretty crazy looking, but it wasn't too bad. Oh no you don't. Alright, next exercise, start off with the odds. Off you go.